Inside Germany's high-speed steel factory, where scrap becomes precision wire. Step into a place where raw scrap metal meets world-class engineering. This documentary takes you inside a modern German rolling mill, an ultra-organized, fire-lit world where every spark, every motion, and every decision is guided by precision. From the moment scrap steel arrives at the yard, to the instant it's reborn as red-hot wire racing through the mill at incredible speed, you'll watch the entire transformation unfold in stunning cinematic detail. Meet Klaus, Hans, Dieter, and Jürgen, real specialists who work inches from glowing metal and roaring furnaces. Their skill and discipline turn chaotic scrap into one of the most essential industrial materials on Earth. What you'll see in this film: massive cranes unloading and sorting industrial scrap, a modern reheating furnace glowing at thousands of degrees, high-speed rolling stands shaping steel in seconds, incredible loops of molten wire whipping across the factory floor, automated coiling systems forming perfect wire rod coils, German-level quality control at every stage, shot with a clean European industrial aesthetic, deep focus, and real factory audio. This film reveals the power, danger, and beauty of steelmaking like you've never seen it. If you love satisfying manufacturing, heavy industry, engineering mastery, or just want to see how raw scrap becomes perfectly engineered steel, this is a journey worth watching.
The scrap to guarantee its chemical composition is within tolerance for carbon and alloys.
This ensures the wire is free from impurities and has the precise carbon and alloy content we need for quality coils.
The preheated steel is delivered to the continuous rolling machine at its optimum working temperature.
And to be precisely shaped to its required final dimensions.
Even with modern systems, transferring material between stands still requires highly skilled monitoring and intervention with specialized tools. In these high-speed conditions, the technician uses specialized heat-resistant guides to ensure the wire's smooth transition into the next machine.
Since full automation is costly, manual oversight requires precision and agility to prevent the billet from cooling or deviating from the stand. In a facility like this, the entire process is meticulously organized, from scrap inspection to final coiling. In a highly regulated environment, technicians must use specific guides to ensure the wire remains perfectly aligned and cool.
Automation is key, but the operator's skill is still vital to prevent cooling issues or misalignment during high-speed passes.
This efficient, direct hot rolling of scrap is vital for reducing our production costs.
By avoiding full melting, we see energy savings of 30 to 40% compared to traditional furnace methods.
However, sorting and precise chemical analysis of the scrap is non-negotiable before we begin processing.
This ensures that the finished product's quality meets all stringent industry standards.
The direct hot rolling approach is typically reserved for dense scrap forms, such as billets and specialty steel bars. Tinting point hatching, or for large production runs of specialty materials. This method significantly decreases the electrical energy requirement of the electric arc furnace EAF segment. A sophisticated quality assurance system is mandatory here to certify the product's mechanical properties. Specifically, the tensile strength and ductility must meet all German and European specifications.
After the wire passes through the final sizing mill, it is guided for immediate coiling into standard wire rods.
We use a high-precision laying head and coiler unit to form the wire into perfect, standard, industry-sized loops. Controlled cooling during this coiling phase is absolutely critical, as it defines the final microstructure, for example the ferrite-pearlite ratio in low-carbon steel.
Precise controlled cooling guarantees the steel wire achieves consistent, documented mechanical properties.
The laying head and coiler unit represent the primary mechanical combination at the wire rod production line's end.